those computations that we have discussed, again, take note, those computations are just applicable for pretension elements or pretension members. So now, for the case of post-tension elements, we have a different way or method of computing the pre-stress loss due to elastic shortening of the concrete. So to illustrate what is that particular way or method to compute the pre-stress loss due to elastic shortening of concrete for post-tension elements, say for example, we have here a post-tension element. So this is the concrete which has an embedded duct wherein the pre-stressing reinforcement will be inserted later on when the concrete already attained enough strength to withstand the pre-stressing force or stresses that will be applied to it or transferred to it by the pre-stressing reinforcement. So when the pre-stressing reinforcement is now inserted on the duct, a hydraulic jack will be placed that will try to pull the pre-stressing reinforcement, thereby uh, making the pre-stressing reinforcement elongate. And as it elongates, it experiences a tension force which is equal supposedly to the jacking force that was exerted by the hydraulic jack. But since in the case of post tension, since we know that for the case of post tension, we know that the pre-stressing reinforcement tends uh, to have friction with respect to the duct or the sheet that covers it. The tendency is that magnitude of jacking force applied by the hydraulic jack tends to lose some of its magnitude because of the friction happening between the pre-stressing reinforcement and the duct or the sheeting that covers it. So that friction force tends to oppose this tensile force acting here applied by the hydraulic jack. Therefore, uh, uh, reducing the magnitude of the jacking force or the force itself being experienced by the pre-stressing reinforcement as the jack applies a jacking force on the pre-stressing reinforcement at this particular stage of pre-stressing operation. So again, after the pre-stressing reinforcement was pulled by the hydraulic jack, after the pre-stressing reinforcement is jacked, again the pre-stressing reinforcements will be cut, thereby transferring the pre-stressing force that it carries to the concrete element. And again, that magnitude of pre-stressing force that is actually being transferred to the concrete element is not actually readily equal to the jacking force, but equal to the jacking force less the magnitude of the pre-stress loss due to friction between the pre-stressing reinforcement and the sheeting or the duct that covers it. Although the magnitude of that pre-stressing force, I mean pre-stress loss due to friction will be discussed later on. So we will not be uh, um, concerned there for this particular topic, but we are concerned on the pre-stress loss due to the elastic shortening of the concrete as at this particular stage of pre-stressing. So uh, after the pre-stressing reinforcement is cut, again, the pre-stressing force will be transferred to the concrete element with the magnitude equal to this. Jacking force less the pre-stress loss due to friction. But uh, along with that pre-stress loss, at this particular stage of pre-stressing for the case of post-tension elements, uh, there are actually other uh, other pre-stress loss that the pre-stressing reinforcement experiences, and that is again actually the pre-stress loss due to elastic shortening of the concrete as the hydraulic jack tends to pull pre-stressing reinforcement at jacking operations. Although that magnitude or that effect of the elastic shortening of concrete with respect to the pre-stress force being experienced by the pre-stressing reinforcement will just affect the pre-stressing reinforcement itself uh, if the pre-stressing reinforcements are jacked sequentially. Although in the case wherein the pre-stressing reinforcements are jacked simultaneously, therefore, that effect of elastic shortening of concrete, uh, that elastic shortening of concrete will not actually affect the pre-stressing force acting on the pre-stressing reinforcement if the pre-stressing reinforcement is jacked simultaneously. So therefore, in that case, we can say that there is actually no pre-stress loss due to elastic shortening of concrete if the pre-stressing reinforcements are jacked simultaneously. Although if the pre-stressing reinforcements are jacked sequentially, there will be an effect to it by the phenomenon of shortening of concrete as the pre-stressing force is being experienced by the pre-stressing reinforcement at this particular stage of uh, uh, post-tensioning operation. So if the pre-stressing reinforcement is jacked sequentially, the magnitude of the pre-stress loss that can be expected due to the elastic shortening of concrete as the pre-stress force is transferred to the concrete element itself will be equal to this formula. So actually, if you will look on references, especially our reference book, our main reference book, NAWI, actually the formula given here is actually very different to this formula. Actually, I just invented this particular formula here. Although the concept on the derivation of the formula obviously is not formulated by me, obviously, so I do not own the theoretical background for the formulation of this formula here, but I just invented my own formula for finding the particular pre-stress loss due to elastic shortening of concrete. Uh, Actually, although with this formula that I have made, uh, is still in reference with our reference book, which is NAWI. Although again, I just invented all of the terms or some of the terms that you see here, especially this, the n minus j over n minus 1. So that is actually the formula for the pre-stress loss that will be experienced by the pre-stressing reinforcement due to the elastic shortening of concrete, wherein n that you see there is equal to the number of jacking operations. So later on, we will clarify what does jacking operation means. And take note the the existence of this term here. This is actually the pre-stress loss due to the elastic shortening of concrete for the case of pretension elements. So you can see here that the magnitude of the pre-stress loss due to elastic shortening of concrete for post-tension elements is actually dependent on the pre-stress loss due to elastic shortening of concrete for pretension elements. So you cannot solve for this magnitude for post-tension elements if you did not first solve for the pre-stress loss due to elastic shortening for the case of retention elements. Although for this particular activity here, for the stage of pre-stressing, you just have to take note for the case of sequential jacking. The first jacking gives maximum amount of loss to the pre-stressing reinforcement. And then the last jacking gives no amount of loss to the pre-stressing reinforcement. So if the pre-stressing reinforcement is composed of several tendons, say for example 10 tendons, and they are jacked sequentially, say for example one at a time, you can expect that the first jacking operation on the first tendon will give a maximum amount of loss that that particular tendon will experience the maximum amount of loss that is expected to be experienced by the pre-stressing reinforcement. And then for the case on the for the case of the last tendon that will be jack, you can expect that uh, that that particular tendon will experience actually no amount of loss due to elastic shortening of concrete. So later on, we will illustrate what we actually meant here. And as an additional note, you can observe that the magnitude of this pre-stress loss due to elastic shortening of concrete for the case of post-tension elements is just has a magnitude ranging from 0 to 1/2 of the pre-stress loss due to elastic shortening of concrete for the case of pre-tensioned elements. So again, you can expect that this magnitude of pre-stress loss due to elastic shortening of concrete for post-tension elements will have a magnitude ranging from 0 to just 1/2 of the magnitude of the pre-stress loss due to elastic shortening for the case of pre-tensioned elements. So this is the minimum magnitude of that pre-stress loss for the case of post-tension elements. And this is the maximum magnitude of that pre-stress loss for the case of post-tension elements. So that pre-stress loss ranges from 0 to 1/2 of the pre-stress loss due to elastic shortening for the case of pre-tension elements. So that is how you can compute for the pre-stress loss due to elastic shortening of concrete for post-tension elements.